Episode 38. This is going to be a really short one because I actually want to get to sleep early tonight. So I'm just going to watch through the tutorial and try to process some of it. It is 9:49 currently. I do want to get to bed this early, like as early as 10, because I really did not sleep well last night. But let's just continue. Let's just get right into it.
There you go. Classes. This is a good one. GDScript is an object-oriented programming language.
No, it's a good one.
This means that we generally try to structure our code inside of contained objects that interact with each other.
Okay, let's see. This is like 11 minutes. I'm probably just going to do... Oh, this is a big section, actually. Okay, I'm probably just going to watch through these two.
We primarily do this using classes. For now, try to think of a class. This is a good one. GDScript is an object-oriented programming language. This means that we generally try to structure our code inside of contained objects that interact with each other. We primarily do this using classes. For now, try to think of a class as a blueprint. Say, for example, we're making an RPG and we need to...
Okay, so this just allows you to make new variables. Am I wrong about that?
populate it with a bunch of
I don't think I am.
characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have.
Or I don't think... What did I say? This just allows you to create new variables. Or make new variables. Or am I wrong? And then I said I don't think I'm wrong. Okay, great. That was great input there that I
So
gave.
for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take this class and create instances. Instances are specific versions of the class. So we could create an instance named Potion Seller that has a health of 50 and a line that says, "You can handle my strongest potions," and a bunch more.
That's funny. That is actually funny. A class has variables.
More instances, all of which have the same variables, but different values, and all of which can talk. "I used to be an adventurer like you," and die. Ah! So that's the idea of classes. In Godot, you've actually already used to be an adventurer like you, and die.
This is funny, actually.
So that's the idea of classes. In Godot, you've actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we are actually also creating a class. I have to put a disclaimer here that we're technically not creating the sprite class. So when we create a script, we are actually also creating a class. I have to put a disclaimer here that we're technically not creating a class, but for all intents and purposes, it works just like one. So let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So search for node and let's name this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X adventurer with a health of 30. And the last character will be our knight, and we'll give him a health of, say, 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. And we can either drag in one of these characters or hit assign and select one. I'm going to choose character 3. And now in our ready method, we simply go to our character to kill and call the die function. And if we run this, indeed, the die function is called on our character 3, which is our knight. So it says knight died. And if we choose another character, say the first one, we are instead killing the potion seller. Really cool. Inner classes.
Here's the thing. Is this necessary even though? Like this, I feel like you could do this in better ways. Character, or class. Export. Okay, and then you choose. Huh. I'm gonna have to do some. I'm gonna have to do some. Okay, why? Yeah, I'm gonna have to do some experimentation or some challenges. Like I'm gonna have to look at some other tutorials that are like challenges and the final product is very optimized to actually learn best practices and how using this would be better than doing other things.
These are classes that exist inside of another class. So we mostly use these for bundling together. Really cool. Inner classes. These are classes that exist inside of another class. We mostly use these for bundling together variables and maybe add a function or two. They can be a good alternative to dictionaries because they are sometimes a bit more safe to use. Say we have this character class here and we would like to add some equipment.
What?
We could create an inner class called equipment. So I'll write class equipment and then we can give it a couple of variables. I'll create an armor variable, set it to 10 by default, and a weight of 5. Now we can use this class around our script. So we could create some variables using it. I'll create a chest that is equal to equipment.new. Calling .new will create an instance of the equipment class. So now we have one piece of equipment, one instance, which is a chest. We'll also create legs, and again we'll call equipment.new. Then in the ready function, we can access these classes. So we can go into our chest and change the armor and set it equal to 20. We can then print chest.armor, or maybe print legs.weight. And this is also where you can see that this is sometimes safer than using a dictionary, because GDScript will recognize that there is a weight variable inside of the equipment class. And if we try to access something that isn't there, we'll get an error before playing the game, not only when we reach this point in our code. This is called being type safe. And now if we run this, we can see that each of the instances of our character will print these two pieces of equipment. And the armor of the chest is 20, and the weight of the legs is 5. Inheritance.
Oh, chest, bro. I thought he was talking about a chest like a treasure chest. I'm fudging. Trolling! Okay, let's see, that was really fast. You know, I am gonna look through this many more times. So I may as well just finish off this video.
So we know that all nodes in Godot are classes, and we can effectively make our own using scripts. But there's one more important thing we need to know to understand how Godot is structured: inheritance. Inheritance refers to the ability to derive one class from another. We've actually already been doing this. Notice how our script says extends node, so our script derives from the node class. This means that all the functions and variables of the node class are also available in our script. Godot actually has a very nice way of visualizing this. When adding a new node, we can see all the nodes available to us, but some of these are organized under other nodes. That's because these nodes inherit from the top ones. For example, both Animated Sprite 2D and Camera 2D inherit from Node 2D. This is because Node 2D is a base class for all things that exist in 2D space. So since both a camera and a sprite needs a position in our world, they both inherit from it. And even cooler, we can actually find our character class on this list as well. That's because when we create a character class, we're essentially defining a new node type. And we can see that it inherits from node. Really cool.
Augers. Wait, okay, that's actually useful. That's actually useful. I think. So basically, you can make your own. Let me think. What would be the like? How would this be better than just making? What in the world is on my desk here? Oh, there's like a hair stuck. Okay. Like, how would this be better than just making a node that you reuse over and over and over again? How would that be better? Yeah, I can't see. I can't see how it would be better, honestly.
Now, all of this probably sounds a bit abstract, because it is, but what it means in most cases is simply that we need to make sure we inherit from, or extend, the right class for what we're working with. If, for example, we're making a script that moves around our player, we would create a character body node and add a script to that node. We could name it, say, player, and as you can see, the script then automatically extends character body to D. And we now have access to all the functionality in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since which moves the node around.
Okay.
Composition in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, such as the velocity and the move and slide function, which moves the node around.
Okay. Inheritance. Okay, I'm not sure when that's going to be used, but that's okay.
Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are, of course, many best practices that we can choose. Check that out. I'm not going to explain
All
that.
right, that's the next one. That's the next tutorial I'm gonna watch. Nice.
Here, since there's already a really good
Okay, but I will look it up later.
video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are, of course, many best practices that we can choose to check that out. Call down, signal up. When writing GDScript, there are, of course, many best practices that we can choose to adhere to. Going over all of them is a video on its own, but one that is particularly important is call down, signal up, which we use as a rule of thumb when communicating between nodes. Every scene in Godot is a tree of nodes, and the beginning of the tree is called the root node, which is the highest in the hierarchy. When looking at two nodes where one is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child, and that child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy, but not vice versa. Instead, call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy. Child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy.
Nodes are fine. Wait, whoa.
Is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child, and that child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy.
Nodes are fine to call functions in the nodes below them on a hierarchy.
Child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy.
Nodes are fine to call functions on the nodes below them. Okay. Sure.
Hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened. The nodes above can then connect to these signals as they choose and act accordingly. Think of it like real life. Parents are allowed to tell their children what to do, but children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents, and the parents decide the next step. Now keep in mind that this is a way to remember a good coding practice. It is definitely not parenting advice. But what if we need to communicate the next step. Now keep in mind that this is a command their parents to do things. Instead, children signal their needs to the parents and the parents decide the next step. Now keep in mind that this is a way to remember a good coding practice. It is definitely not parenting advice. But what if we need to communicate between step? But children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents and the parents decide the next step. Now keep in mind that this is a way to remember a good coding practice. It is definitely not parenting advice. But what if we need
But what? What was controversial? What was like bad about what he said? Nothing.
to communicate between two nodes
Whatever.
that are on the same level? You guessed it, these are called siblings. Well, here the common parent is in charge of connecting the signal from one sibling to the function on the other. This is most often done in the ready function right at the beginning. So that's the idea of the rule, but of course always implementing this concept correctly requires some practice. I'll have a link to a good article with some nice examples. Style. During this video,
Okay. Why? But like, but like, why do you need to do that? Why? Well, like, why is that a rule? Why is that a best practice? Why do you need to do that?
I've tried my best to
Okay,
adhere to the
whatever.
official GDScript style guide. These are the conventions we use for naming and order to keep our code elegant and readable for others. I won't go into further detail here, but I'll have a link to the official guide. That was a lot of code for one video. Of course, I haven't covered everything you're ever going to need in GDScript, but I hope this served as a nice overview of the most important aspects. Also, don't forget to check out Codecrafters. Become a better software engineer today by using the link below and get a free week and 40% off. So, this is the last video we've prepared for now. If you liked our new videos on Godot and have a topic that you would like to see covered, please let us know. While we don't know what the future holds, we've had a blast making these videos, and I hope you've enjoyed watching them. So, until next time, stay awesome and funky.
Insane. Insane. Sure. You get a like. Alright. That was interesting. That last bit there. Yeah, I'm gonna have to see the use cases because I feel like you can do a lot of things simpler, a lot of things a lot simpler than making classes. Like than making a bunch of different objects for stuff. Like it just seems excessive, you know? I mean, unless you count making like I don't see a reason you would need to make a new class. I don't see a reason you would need to make new classes. But I will do some exercises. Yeah, I will do some exercises to get better and see the use cases. In the future. Alright, that's it for this episode. Thank you so much for watching me. That should have been episode 38. And you will all see me tomorrow.